Hello everyone and welcome to our sessions on digital heritage inspection and survey, which are kindly funded by Historic England. This is a programme of 10 sessions for learners of different experiences and backgrounds to find out more about how digital models and digital twins are being used in the heritage sector. There's a WhatsApp group where the learners can co-mentor and share resources too. My name is Linda Jubb and I'm your host today. I'm a Chartered Building Surveyor and Fellow of the Royal Institution of Chartered Surveyors. Our practice, Jubb Clues, specialises in the survey and repair of historic buildings. Today's session of our series about digital heritage inspection is the second part of our section on people. And in particular, this time we want to concentrate on risk management. How do we safeguard the people that we're working with? How do we comply with the regulations? And what are the ethical implications of what we're doing? I'm really delighted that today we've got our guest, John Bedford, who's here, who's been an absolute champion of this project. And I'm so delighted that you've been able to come today, John. I know you're on a short time scale, but if you've got a mo to just say hello to everybody and let them know a bit more about you.
Hi, everyone. I'm John Bedford. I run the geospatial survey team at Historic England. So we're a small team that work nationally, and we spend all of our time pretty much recording historic buildings for a variety of reasons. That sort of ranges through from heritage at risk, buildings on the heritage at risk register, which I think we'll touch on today. Right through to most of the English heritage estate. So that's an estate comprising around 400 properties in care of the state across the country. And we're doing a lot of the sorts of things on a day-to-day basis that you've been being shown by Linda and others in the run-up to this lecture. So I think that's enough. I'm happy to be contacted by anybody offline if you want, and Linda can supply an email address for contact.
Thanks, John. I think the most important thing is that you're a practitioner and you're out in the field a lot of the time and doing this on a day-to-day basis. So this isn't just a theoretical oversight. So today what we want to run through with you is the statutes, the actual legal framework for risk control in site work. It's important that we cover that off today. There's a little bit about data protocols and security, and we might think a bit more widely further on in the session about the principles and ethics underlying this, because I think we're moving into a world, and I think I'm going to mention the AI conference that occurred recently, where individual judgment, professional skill and judgment is going to be more important than just slavishly following the regulations. It's never worked in health and safety, and it's never going to work in digital cybersecurity either, I shouldn't think. So in terms of the legal duties, most of our legal duties come to us through the Health and Safety at Work Act 1974. That's that monument of legislation in its own right. It's operating through a set of regulations, the Health and Safety at Work regulations, which were much later, 1999. And this introduces the concept of risk assessment, which is first of all looking at the hazards in the business. What is it that could go wrong here? And then thinking about risk in terms of how likely is this this hazard to occur? And then working through a system of risk reduction and mitigation to try to either eliminate the hazard, reduce the risk, find a different way of doing it. And of course, that's where our models and the work we've been talking to might well come in as a way of dealing with those risks. So it's a virtuous circle. And the reason that it closes, as you'll see, as you go through the hazard assessment, risk control process, is that then there is a reflective process whereby we go through checking what we've done, and also really critically in terms of the law, consulting with the employees or consulting with the workers, because they may well just be co-consultants or people whom you meet on site who happen to be in your workspace, to see whether what you're doing actually works. And that's another big part of our work here, of being more collaborative, is to be able to share our best experiences and also be critical about things that didn't go well so that we can do them better in future. That's a cornerstone of health and safety law. Of course, like all health and safety law, it comes down to filling in a spreadsheet. So it's actually very straightforward. Start on the left, listing out your hazards, think about who's affected, what your risk control measures are, and so on. We use this kind of risk assessment all the time. The risk assessments are known as RAMs, and that's why I've got a little picture of a sheep so you can remember. RAMs stands for risk assessments and method statements. And so the method statement is how you actually prescribe the work will be done. You've made a lot of options and said, no, we've decided we're going to do it this way. We share these with our client. And the reason is that we want them to be involved in the decision making and to understand there may well be a cheaper way we can do it, but it might not be safe enough to do it that way. And our duty is to try and put the safety first. So the method statement will almost be a sort of narrative, a description of how work is done. And it might even end up being part of the specification for the work in the end. We always do them bespoke for every project because it gives an opportunity to learn from what we've done before and also take into account the specific hazards of that site. One of the other reasons that we share these with our clients and we share them with our co-consultants and contractors is because of the CDM regulations. CDM stands for Construction Design and Management. And since 1995, when these regulations were introduced, start of my career, we've seen real progress in reducing the rates of death and serious injury in construction. And the reason is that it puts an onus on clients to be involved in every part of the supply chain. That the hierarchy of responsibility goes back to the client, and one of their key responsibilities is to resource the project correctly. So it's quite legitimate for us to say to them, look, this isn't a safe way of doing it. We need you to invest more in survey work, in precautions, so that we can get a good result for you. And everybody in the supply chain has that right. When you take that into account with this duty to consult with others, which is in the Health and Safety at Work Act, these are a really powerful set of regulations. Sorry, my slide doesn't appear to be displaying properly, but there is some guidance from HSE. This is the client guide that I can see on my screen here, but there are two others which I don't think are displaying. Ah, there they are. This is the overall guide that we rely on, which has got, I'm sorry, I'll have to give you the reference at another time. It's not quite legible there. I think it's called IL 35. And this is the one that's for contractors, small contractors. And this one over on the right is for clients. There's also subsidiary guidance, the working at height regulations, which I'm going to come back to when we talk about drones and drone safety. Surveying safely, which is a professional practice guide for chartered surveyors, but actually it's been put together by lots of people with different safety and survey training to try and protect everybody during the inspection process. And there's also guidance about workspaces as well. You know, for instance, are you using display screens? Do you need regular eye tests? Have you got an ergonomic workspace? These are all part of our considerations when we're planning work to create these digital models. So in terms of risks, I've sort of broken it down a bit, and if in the chat you can put down any other risks, hazards, things you think we ought to be thinking about at this stage. But in one of our RAMs, our risk assessments and method statements for doing such work, we'll think about this in terms of different things that the surveyors are going to encounter. We've got to get all the stuff to site. Some of it's quite heavy and a bit bulky, and you might have to park a long way away. So obviously we'll take measures to make sure that they can get their equipment safely into site, and that they don't feel like it's going to be stolen. I mean, that's an issue at the moment, or that they're at risk of being assaulted or anything going wrong like that. We tend to avoid lone working wherever we can. We don't like people being out in the field on their own. We're going to talk about unstable structures. You've seen in the case study that we did earlier that working with heritage at risk in particular, some of the structures that we deal with are in extremely poor condition. But I would advise that any structure should be assumed to be in poor condition until you know different, until you've actually been there and you've done your assessments, a dynamic risk assessment on the day. You don't assume that the floor is strong enough to take you. You assume that it isn't, and then work from there until you can satisfy yourself that it is. We'll talk a lot about working at height. Slips, trips and falls, unguarded falls are another major cause of accidents on site. Obviously, when we're working at occupied buildings, and we very often are, we have to think about what kind of people will be there and what their focus will be, especially if there's vulnerable people. We very often have to have DBS checks, and we put in special safeguarding measures. Our preference really is to go and do our work when the building users are not there, and that avoids any conflict between building users and surveyors, as tripping over each other's equipment and generally being in the way. Traffic collisions on a busy site. We think about asbestos, methane, which is a problem in confined spaces, leptospirosis, flooding, waterways. I could go on and on. There's lots of different ones, but those are the ones that I've just put off the top of my head. The particular environments with the modified risk assessments are the ones where there's the security and safeguarding, schools, hospitals, care homes, and so on. Building sites, railways and highways, there's a whole set of regulations around working on the railway and working on the highway, and vacant buildings and working over water. And John's probably just thought, well, that just sounds like an average day, all of that. So I'm going to think a little bit about this business of unstable structures. And I did promise you that today would be Bring Your Pet to Work Day for John Bedford, because he's got a very special way of dealing with weakened floors. This is an example of me standing in a building where I hope you've got the soundtrack playing as well. Looking at part of it that just fallen down. There's my foot in my asbestos suit. And one of our attendees here today, Jack Johnson, will recognise this building. And that terrible clanking sound that made me clench, and I will never unclench again, because just trying to consider how we look at and record something like that. And here we have it, John's pet. Can you see it? Just there. I'm going to hand over to John. You can tell us a bit more about this project.
Hi, Linda. Have you got a different photo of him where he's a bit more visible? There we go. So this is one of the tools that we use for accessing unstable or unsafe structures to gain survey records without having to enter the space, without having to put people into the space. So there are two sort of strands to this. The first is that you can see that this is a Boston Dynamics robot dog. He's remote controlled, and stuck on his back is a 3D laser scanner. And what this enables us to do, these are the sorts of instruments that we're using on tripods all the time outside. So we can scan around the outside of a building using that instrument, mount it on the dog and walk it inside. And then we've got the same quality of scan data from inside and out. So we're using this, principally as a means of mitigating risk. It means that we can survey extensively damaged buildings which are accessible from the ground. It can walk over debris. It can step over obstructions up to about 30 centimeters in height. If they're bigger than that, it walks around them. And we use this to gain access to buildings and structures, as I say, that we can't put people in. It's one of a suite of tools that we use for mitigating risk under these circumstances and for getting good survey records. the other one, I think that middle slide there, you can just about see. There you go. That's an Helios remote inspection drone. It's in a cage, so it can bounce off things without damaging the drone. But we also use that to a huge extent. Actually, it's got a LiDAR laser scanner on it. The quality of the data is nothing like as good as it is from the scanner on the dog. But this allows us to enter buildings. When we're looking at dangerous buildings, very often the ground floors are completely, they've been made inaccessible for very good reasons, for safety reasons, to keep other people out. But we can use this drone to go in either through the top if there's a hole in the roof, or through upper story windows if they're accessible. And we can fly that around. The Helios has some limitations because it's running a lot of kit. We've got 4K video, we've got a LiDAR laser scanner, we've got LED lights, all sorts of things like that running on it. Battery time is limited. We've got about 9 minutes of flight. So you're sort of really 6 minutes in, 3 minutes out each time. So it's an iterative process. We'll record one part, take it back, record another. The dog is rather more generously sort of, it's got a much better battery life. We can get about an hour to an hour and a half of use out of the dog before we have to change the battery and bring it back. For the drone, our ranges are limited by things like Wi-Fi. For the dog, we use mesh radio communications, which in theory can allow us to communicate with that over 5 kilometers. But, in practical terms, it means that we don't lose sight, we don't lose the connection with that sensor, with the dog itself. Through buildings with very, very thick walls. We habitually are working with, many of the places we work at have extremely thick walls, especially in basemented areas. So we need to maintain comms, otherwise we can't get it back. And that remains an issue with both of these, all of these, remote inspection tools. You really have to pay attention all the time, because you've got no chance of getting something back out of that structure in most cases. The dog is a very useful tool, but it's also very expensive. So we are mindful of that, and we make, dynamic risk assessments as we're going along. We get real-time feedback back from that. If we are not sure from what we can see with the dog that a floor surface that we're about to walk over is safe or not, we won't go across it. It's as simple as that. We're not prepared to risk that useful equipment in the event of doubt. But in the case that you can see here, both of these, the left and the right, these on the left, you've got two shots from a First World War aircraft hangar at Old Sarum Airfield. It's the roof construction was Belfast trusses, and I don't know if you know anything about these, but there's almost no redundancy in that structure at all. So once one of those members goes, the others will, it'll overload every other member in that roof. So catastrophic collapse, as you can see in the middle picture, happens quite quickly after the first faults are noticed. On the right, we're looking at a Grade 1 listed barn at Winterbourne, Clenston in Somerset. Again, it's been scaffolded. That was before the roof collapsed. But we're able to get the dog in. It can walk over all those tiles, and we're producing drawings that are allowing the engineers to design propping and other systems to go inside and save that barn. I don't know if there's anything you want me to add there, Linda.
I'm slightly stunned. I'm slightly stunned. Does the dog have a name?
No. Boston Dynamics, who we got it from, called it the Spot. We just called it Spot. As you can imagine, we were inundated with suggestions for names for it when we got it, but we just
Doggy McDogface.
Well, yeah, that sort of thing, yeah. But but we kind of steered clear of that. I mean, we think of these things very much as tools. They're just ways of gaining access to places that we could not otherwise safely enter by any other means.
And,
And
then the affordability of these. I mean, surveying practices at the moment are not investing in these, and I think that's something that's very special about your team and the surveys that you do, John, is that you do actually go to places where other surveyors won't or can't.
that's right. I mean, it's the nature of our work that we are often asked to survey buildings that are in a really quite dreadful state of repair for one reason or another. And we take our health and safety and our risk assessments very seriously. The last thing I want to do is for something to happen to a member of staff.
Mm.
So for us, it was you know we don't operate as a commercial business. We're historic England, but we do get what you might call a return on our investment for these things, in that we're getting the survey records that are necessary to save structures that could not be got by other means, and in circumstances where really no right-minded survey company would send a person in.
Nor would they send in an £80,000 dog.
Well, nor would they do that. No, but we do these things often enough that that that's it. That investment was worth it. We think.
Yes, it's one of those things where we want to be more cohesive, because just because our individual firm or the usual surveyors that we work with can't do something doesn't mean that it can't be done. And I think there is real scope for collaboration there, because
Absolutely.
this kind of kit, even your standard laser scanner, um, I suppose it's a bit like the MRI scanners in the hospital. I mean, ideally, we'd have them working around the clock. Then we would need fewer of them, and we could be more efficient. But then you'd be working in shifts, and the amount of skill and care that the operator needs in order to run the machine safely for
Yeah.
themselves and also not to damage the kit is
Mm.
one of the key constraints. So, but there's usually a way that we can get some data. And the other thing that you rightly point out is that understanding structure, such as these Belfast segmental lattice trusses here, and knowing the mode of failure is so critical to the dynamic risk assessments that you're making. And I've got a slide coming up, which is me working with John Avett from Man Williams, Tom Martin's here from Man Williams Structural Engineers as well, about how this is a team sport. We have to make these decisions together. We have to constantly, in these dynamic risk assessments, check in with each other, because we've all got something to contribute. It might be another way of doing it and getting the data, or it might be something that is not obvious about how the structure is going to perform in those circumstances. I'm trying to move the slide on for this. I don't know why I've got, there we go. So I've got a little bit of footage that we took from an internal drone. So I would use this as a bit of a hierarchy. Let's go with a terrestrial laser scanner, as long as it's safe to do it. If it's not safe to do it, we still want to be terrestrial, because as you were saying, the accuracy using spot is better than if we go for an internal drone. But if you're on a very unstable floor, you're not going to put RoboDog in, because you might get hurt. So, so then we'll go to the internal drone flights. And this is the machine you call the Helios, which is actually carrying the scanner on it. And that's the SLAM technology on that one, is it, John?
Sorry. Yeah, that's right. Yeah.
So there's a slight sacrifice in terms of accuracy on that, is there?
Um. Yeah. The point clouds are less dense. It's using a not a survey grade scanner. It's a well, I mean, it's a survey grade scanner. It's a SLAM scanner, but it's designed to work in mines and other places like that. So the range of the scanner is limited, and we're happy enough now working with SLAM data. We use a few SLAM scanners, and under the right circumstances, they can work really quite well. Our philosophy with this thing is that this is getting us data where we would have no other means of doing it, so some is better than none.
Yes, I agree.
And we can make assessments. We estimate that in the smaller areas, the more enclosed the area, the better the SLAM will do. We're looking at estimated errors of sort of 3 to 5 mil in these sorts of point clouds, which we can to an extent tighten up with by using our other scanners.
Because we've been using cameras, ordinary video cameras within, this is an internal drone flight. And we use this as part of a step further back in the dynamic risk assessment. But we've spoken about this building. This is another one that Jack Johnston here is looking after. I always say, shout oi oi when you see the drone operator, because he'll be somewhere in line of sight. But we use them to fly through where we suspect that the floors are this floor is too weak to walk on, but we might be able to find a pathway through for robo dog, or we might decide that this is safe to fly with the INEOS and plan our flight, as you say, to exploit those 9 minutes that you've got before your battery is coming down. And for this example here, we think that we might be able to get quite a lot of data through the openings, as long as we can get up to them on the outside. So that really concludes that section. Sorry, I'm struggling to move my slides on. So the next section, John, I think we're going to talk a bit more about working at height. And the obvious way of overcoming heights that we've talked about quite a lot already, but I need to just go back into risk assessments and talk about the regulations a bit more, is using drones. This is quite a big drone, a drone that belongs to Bury Associates. And Yarrow, who's flying it there, is just carrying out his pre-flight checks before he sets off. And that will be on a predetermined flight path. I mean, the whole flight path will be planned out beforehand. The smaller drones are becoming more and more accessible now. And that means that you can get more of this kind of imagery. The risks of flying a drone to be weighed against the risks of either roped access or scaffold access, or however you're going to get up to height, are that there's a risk of collision, obviously, with the property and the trees and so on. Collision with the public. Obviously, aircraft and airspace is a major safety consideration. Bird strike, and we try to consider ecology in general, in terms of protected species, bat habitats and so on for the flights. The weather is obviously a major constraint, wind in particular, but the rain and visibility will also be taken into account. And overcoming the constraints of trespass and lone working, you always need the landholder's consent to fly a drone over their land, and thinking about people's privacy with these other views that you get. If you don't mind, I'm going to hand over to Richard, who knows quite a bit more about drone pilot regulations.
Drone use is rapidly expanding in the UK. It's promoting continuous evolution, and the regulations trying to keep pace. There's a few key rules when we're using the drones, and the main one is the drone's always got to be within a line of sight of the person. The person flying the drone, the pilot, is always responsible for the safety, both of the drone, the public, and anyone involved in the operation. This means working within the craft's controls and capabilities, checking the conditions, and using specific precautions. Some airspace is fully restricted, particularly around airports or military sites, sensitive areas. There's different regulations based on the weight of the drone, the size, and how you're using it. For most people that are using smaller drones below 250 grams, all that's required is an operator ID, and the key trigger for that is if the drone has a camera. Obviously, for the work that we're using the drones for, the camera's pretty much essential. So for that small drone under 250, you need your operator ID and check that the flyer is competent. It's a simple online multiple choice exam. There's lots of guidance available in terms of how to fly the drone, what to do, what not to do. And we can put a link to this useful guide into the chat if needed. If we can jump over one more. Moving on from the 250 gram drones, the next step up is the A2 class. And to fly in the A2 class is a course called the Certificate of Competence. This allows you to fly a drone up to 2 kilograms, but it does introduce some additional restrictions. You can't fly over people uninvolved in the activity. So if it was a public area or in a town centre, you need to keep 50 meters horizontal distance between the public and your drone. Whereas if it's a smaller 250 gram drone, you can overfly people uninvolved in your activity. But again, factor in different risks the larger aircraft may bring as opposed to the smaller ones. And then comparing the risk assessments for the drone inspection versus a traditional person in the building. I think the terrestrial inspection involves using equipment such as the laser scanners, total stations, GPS. And obviously that as a person in the building for a longer period of time. The drone inspection, we remove that physical risk of the person, but we introduce new risks with gravity, props spinning around very fast, and risk of disturbing asbestos that maybe wasn't there before.
I'm really grateful for you doing that. Both you and John just going through those different tools that we've used, drones, dog, internal drones, and some of the regulations. One of the constraints that we would be taking into account when we're planning these inspections is also asbestos, and you touched on it there. Asbestos is a major constraint on using drones internally because we don't want it to become airborne. It's also a major constraint on putting technicians into space using the scanners. So in terms of the risk assessment, we go through a number of phases. We have got access to do some investigation. This is John Avon in asbestos gear, trying to make an assessment about where the weak floors are. You've got to start somewhere. Can you get into the building? Is it safe? Then we risk assess for the asbestos and carry out tests and so on in the areas that the asbestos surveyors can get to safely. Then we might carry out some stabilisation, and the picture on the right is where we've used a laser scanner with our asbestos protective gear, but after the use of, I think in that case at Burnley Empire, it was a PVA spray glue, wasn't it, to make sure that the asbestos that was on some of the surfaces did not become airborne, because otherwise you'd then write off the equipment, and this equipment's too expensive to use it in that way. We have similar sort of risk assessments that we do when we're doing rope access or when we're working in confined spaces. We work going back to that principle of putting together the risk assessment and the method statement. And it's a dynamic risk assessment. So we think about how we're going to do it, we get on with it, we go step by step, and as far as we can safely. And then we will withdraw and make some decisions about whether we can go any further and whether we've exhausted our exploration. So the next section of our session today is going to look a little bit at what the regulations are around data security. You'll have heard me discussing GDPR. This is the data protection regulation, which controls personal data. And the governing body for that in the UK is the ICO, which is the Information Commissioner's Office. The rules around data protection are that the data must be used fairly, lawfully and transparently, and used for an explicit purpose. So when we're collecting data from sites, one of the things that we have to do is try to redact it, sort of pre-redact it, either make sure that we're not there when other people are there, that they're not inadvertently caught in our views, and so on. And that if for any reason their data does come into our possession, it's sort of ring fenced so that we can delete it as soon as possible thereafter. There are hazards as well about where we keep the models as well. You know, if somebody gains access to the model, they can find out about our client's property. You know, some of the security of the property itself might be compromised. And there's also the intellectual property, so sort of the designs and for factories and so on, processes that go on inside those buildings, which will be accessible through these models. So that's another reason why we have to keep them securely. Failure to comply with GDPR law could result in a fine. And if for any reason we lose information or it's not accurate, there are also consequences for that. We have been following this guidance, which is the National Cybersecurity Centre, the Cyber Essentials, and that's how we set up our cyber security. But there's more than one way to do it, and I do encourage you to look into that before collecting and storing this kind of data. The next section that I'm going to deal with is to look at this through the lens of principles and ethics a bit more deeply. I mentioned conservation principles earlier this afternoon. Conservation principles is this document here, which is provided by, it was drawn up when Historic England was still known as English Heritage. And it deals with the policies for historic environment. It's very much about sharing information. And so the underlying principle is to share what you can, but also to safeguard what you can't. That's the way we would look at it. There's also guidance about professional ethics from Chartered Institute of Archaeologists and from the Institute of Historic Building Conservation, all of them very relevant for the heritage sector. What I would say in summary about the heritage sector when compared with construction sector or property sector as a whole is that we're very much more about sharing information and collaboration, and we're very much more about publicly accessible records and record keeping. It poses ethical issues, and it's been an issue that's been frequently revisited, both in business and in academia. I want to signpost you to the UK Centre for Data Ethics, which is part of DCMS. And there is a data ethics framework, which I understand is under review. More recently, you'll have seen that ethics has been one of the areas where agreement wasn't reached this week at the International Conference on Artificial Intelligence. Here in the UK, we have the RED Foundation, which you can look up, which looks at data ethics principles for property. So behind all of these models is the opportunity to share information, and that information could have economic value in terms of, say, these automated valuation models or whatever. But what's more likely for our sector is that it will just make us better at what we do. So that is the underlying principle that I want us to consider. As I say, our baseline is to just not collect the data that we don't think we need, to be careful about, you know, blanking out number plates, never take images of people's faces, children, make sure all the documents are turned over when you're going through other people's offices, and even people's private photographs and so on when we're looking around their home. But that might be something for you to bear in mind, is when you're going out and you're taking this amount of data, you know, endless photographs and so on, is where are you keeping them? What are you keeping them for? And are they going to compromise other people's rights? I also wanted to just make a note about the culture for investigating accidents and near misses in the use of drones, because actually it's quite interesting for our overall ethical context. The National Aviation Authorities operate a just culture rather than a blame culture. And it's something that came up in public recently when there was that horrible crash between the helicopter and the airliner in Washington, and straight away there were sort of public announcements about how that might have happened. That's not actually how our investigation works, that it's a very process-driven investigation, and it's neutral. in terms of actually trying to establish what the issues are. And this provides a framework so that the risk can be managed down. And I think it's really important, the way that we work with data now is to be inquisitive about what its limitations are, and also to be very fair with each other about how we investigate things when they go wrong, because our only opportunity of really improving in this sector is going to be very objective about it and open to the benefits that it's going to bring us. And I think that came out really strongly at the International AI conference this year. I'm using jargon again, artificial intelligence conference that occurred this week. So overall, I wanted to make 2 points about ethics. I've put the green heart over here for Grenfell, because we do have to now think very carefully about the frameworks and the risk assessment models that we've built for ourselves. One of them is the legal principle of duty of care, which is whereby something that I do over here could affect somebody over there who isn't necessarily my client or directly involved in the project that I'm doing. And this legal principle about tort and negligence is that we have a saying when people come and train with us, the surveyor is responsible for everything, and that feels a bit oppressive and overwhelming. But in actual fact, there are consequences to nearly everything we do. And as long as we can take responsibility for all of the unintended consequences from our work, it makes us more focused on being careful and doing it without harming people. The second principle is the duty of candour, and this is more related to that example I gave you of just culture for aviation authorities, but actually it's most established through the health and social care sector. And this happens when there's investigations about sort of systemic errors that have happened in people's care. But the duty of candour means to be truthful and to build trust between the parties. And I think that's also extremely relevant for the way that we develop ourselves in terms of our handling of data and these kind of very powerful processing systems that we've got, because it's easy to get caught up in what they can do and what we will do with them, and not why we're doing it and what constraints we should impose on ourselves and other people in a high level risk assessment context. I'm going to take a poll, because it's always poll time by about now, isn't it? Do you feel more confident about risks and issues around making and using digital models for the information we've given to you today? I really didn't want to put anybody off, and I hope it's not been overwhelming, but do please let us know if you did feel like that, because we will do our very best to help you. I'm really delighted. It does look as though everybody got a bit of comfort out of this, and I will share with you all of those regulations and background stuff. And if you do still feel uncomfortable about the risks of the work that we're proposing, do please come and discuss it with us. That's what we're here for. I've got time for a few questions. Yes, there's a question from Vivek. These literature, are they available? Yes, some of it's available on Historic England's website, and we'll send you out a pack with those links and data in there for you. Thanks so much to John Bedford, so much to Tom Martin. Thank you to Richard for co-presenting with me today. Thanks again, everybody, for coming, and I'll see you next week. Thanks, bye-bye.